How's it going, everybody? Wanted to go over a lesson real quick on Dhcp, and it's not going to be a complicated topology, but I had a couple people ask me, well, I understand the concept of Dhcp, but can you explain and maybe implement and throw some twists at it and help us figure it out? Because when I released the CCNA4 lab, the final lab, where I walked through the entire lab itself and explained everything, when I set it up, I misconfigured a few things, and this is kind of the fill in the gaps, that weren't done correctly. And not to say that I did incorrectly, but actually I did. And with that being said, there's some things that need to be need to be explained and stuff like that. So basically, as you can see, we have a little list here of things that I'm going to explain to you, and how it all works, how it all comes together, and shouldn't be too long. And anything that we run into, I'll try to work them as quickly as I can. We shouldn't run into any problems, but if we do, we'll troubleshoot them, because that's what you do when you implement things: is you configure, you verify, and any configuration you do beyond a working topology or working configuration has a potential of breaking it. So it's one thing you as the engineer or the technician will have to do, is once something is implemented and you get a call, hey, this isn't working, it's your job to figure out why. So we'll quickly walk through that and figure out where it is we need to work, and go from there. The concept of Dhcp is real simple. Let's say, for instance, you have a network of 200 users and everybody uses desktops. Well, you could do IP addressing one of two ways. You can either statically assign every assignment to each computer, meaning go to each computer, statically assign it to the IP config section and under the IP version 4 properties, or you can automate it using Dhcp. Well, what is Dhcp? Dhcp is the Dynamic Host Configuration Protocol. Basically what that does is it takes a pool of addresses that you have predefined on a server somewhere, whether it's router based or server actual, like Windows 2008, Linux, Unix, it really doesn't, Mac OS X, I believe. I don't know any of the Mac server platforms, but that's what you would use, and it would be this Dhcp server. So with a Dhcp client, the router would act as a server. The client down here would send out the discover offer request acknowledgement, and what that does is it sends a discover broadcast message to the Dhcp server. The server responds with an offer of an IP address. And the offer, the request, and the acknowledgement are all unicast. The client receives the offer of the IP address, sends a unicast back to the router or the server and says, yes, I want that, that's the request. And the server at that point says, okay, you have that IP address now. I'm taking that out of the pool and putting it into a binding, and that binding, or the acknowledgement, is sent back from the server to the client, and the client receives it as its IP address until the lease expires. Typically a lease could be 7 days, and you're going to set an auto renew policy set up where it'll automatically, at say 3.5 days, say, okay, I still have this IP address, this is the one I want to use, so it'll automatically renew it. You won't ever lose that IP address. Most home networks run off of that. So you'll set Dhcp up, it'll get an IP address, and 99% of the time you'll always end up with the same IP address, unless you do an IP config / space / release and space IP config space / renew. And then, but in most cases Windows remembers what you had and will request the same one. So that's basically what Dhcp is. Dhcp relay, well, it does the exact same thing that Dhcp does, except for the fact that it takes the incoming request, say for instance on fast0/1 right here, it takes that request and forwards it out fast0/0, where it knows that there's a Dhcp server somewhere here on the remote router. So once the discover offer request and acknowledgement still works the same, except for the fact that it takes that broadcast initial connection into the fast0/1 and for the discover, and instead of taking it and saying I don't know what to do with it, it forwards that discover request out to the remote router, and the remote router ends up getting a TCP connection back and forth to the end device. So what ends up happening is that relay agent is this router right here, sends all the information back and forth between this router and the end user, and that's how relay works. The helper address is how that's done. So what you would do is underneath the individual interface, and if you notice, we have one physical interface and we have two subnets. Well, I'm going to configure inter-VLAN routing, and it should only take me a couple minutes to get that up and running, but I wanted to give you an idea of a real world implementation. You're not always going to have the luxury of having one subnet per port. You can have multiple subnets on one port. You're just going to share the bandwidth, share the load, and what ends up happening is you configure sub-interfaces on each one of those on this physical interface. So you could have, say, 100 different networks coming to the same interface. It's not a scalable solution, but it's a workable solution. If you have a smaller environment, you don't need some beefy 3550s, 3560s, 3660s. I'm sorry, not 3660. It's a router. But yeah, that'll work too. You don't need a beefy layer 3 switch to do your routing. You can have a router, connect to a couple of switches, and there you go. So what I've done is I took 3 switches, 3 2950s, connected crossover cables between the 2 switches down here for inter-switch communication, and the router is connected to the switch via straight-through cable. I'll configure router on the stick here, this is actually going to cover a couple different things. It'll not only cover the fact that you guys will be able to see VLANs and how they're situated, how inter-VLAN routing works. I'll configure Dhcp for those individual connections and go from there. So let's get started. The first thing we're going to do on the router here, as you can see, I turned the interface on so it was all pretty green. So, forgetting one thing. What's a VLAN? A VLAN is a virtual LAN. What that means basically is you can have this switch. As you can see, it's everything by default. You look where all the ones are next to the down. Everything by default on Cisco devices, specifically switches, is in VLAN 1 by default. You can't delete VLAN 1, you can't modify, change, edit, or reboot the switch. VLAN 1 is always going to be there. You can't do anything with it. So, well, you can, but you can't make any modifications to it, like delete it, or, I mean, you could take all the ports out of VLAN 1, you know, that's doable, but by default, all the ports are in VLAN 1. So what we end up doing is we configure, say, this guy will be VLAN 10, and this guy over here will be VLAN 20. Okay, we're going to set that up. Now I know I set up 1.8 and 1.1, two different subnets based on the CIDR notation here, /29. That's 6 usable host addresses. So if you know your bit increments, /30 is 2 users, that's the 4-bit, /29 is the 8-bit. So subnet and broadcast IP aren't able to be used as usable host addresses, so it gives you 6 addresses. We only have 2 hosts on each subnet, so we're okay there. So we're going to click on this guy, and we're going to hit enter a couple times. Well, hit enter a couple times. We're going to go to global config mode, and since I already have fast 1 already turned on and up, and fast 1 is going to be our interface. So we're going to go into interface fast 0/1, and we're going to hit the question mark. We have 2 choices. We have the slash here or the period. What happens when we hit the period? Question mark. Well, what's that mean? Well, we have all these numbers down here, 4.2 billion. Well, that means we can have 4.2 billion sub-interfaces. No way that the router's ever going to be able to come close to that. So we're gonna just kind of go with this. Make this 10 for the VLAN 10. Hit enter. It brings up the logical interface. Now these are all logical. Anything is going to be logical. So we're going to go ahead and we're going to type in encapsulation .1q 10. Why do we need to do that? Well, in order for a VLAN to travel from the switch here to the router, the router to make the decision of as to which VLAN is going to connect to and back down this trunk interface, actually the trunk connection. It has to be told what encapsulation, what VLAN encapsulation, what trunking encapsulation, I shouldn't say VLAN encapsulation, what trunking encapsulation to use across that line, or this link right here. So .1Q. So we're going to do the same thing here. And then we're going to type in, now, this is per sub interface. So we're going to go up here, .20, that brings that one up. And we're going to do the same thing with him. There. So now we're going to go back to, we're on 20, and we know 20 is the 192.168.1.8 network. We're going to go ahead and we're going to type in IP address is 192.168.1.9 because it's /8, or it's a .8/29, 255.255.255.248. It's got a match. There. Type in, we're going to go to interface that one, we're going to type in IP address. Type in 192.168.1.1 and we're going to type in 255.255.255.248. Now, why did you say .8 or .9 there, but you put .1? Well, because .1 is the first usable IP address. Oh. So, now that that's working, what we're going to do is we're going to exit out, then we're going to type in two things. We're going to set up the excluded addresses and the actual DHCP pool that we're going to use for each interface, or for each LAN segment. So what we're going to type in is, type in IP DHCP, type in excluded address, type in 192.168.1.9, and enter. Well, that finger thing's over here. And .1. What does that do? Well, what that does is if you do not put this in here, it will assign the default gateway to each subnet as a usable host address to give out a DHCP request. Well, we don't want that to happen. So now these IP addresses are not going to be assigned when DHCP requests come in on the router's interface. So we're going to go into, since we're still here, IP DHCP, type in pool, question mark, word. We're going to type in LAN 1. We're type in question mark, default router. This is going to be the default gateway for LAN 1. Type in 192.168.1.1. Excuse me. 255.255.255.248. Oh, my bad. And then we're going to type in DNS server. What I was trying, this syntax right here is for the network command. So we're going to type in DNS server 192.168.1.1. Enter. We'll type in network, and then we're going to copy and paste this. Make sure I copy just the right amount. Copy. Paste. Done. Now what we're going to type in is IP, or actually we're going to exit out. Type in IP DHCP pool LAN 2. Now we're in DHCP config mode again. We're going to type in default router is 192.168.1.9. DNS server is the same, 192.168.1.1 or 9, and then the network is going to be 192.168.1.10. Oh, see, I goofed up right here. I can't do that. I'll have to re-enter that information. 1.10, 255.255.255.248. So what I'm going to have to do is, now that's configured, exit, type in, go up a couple here. Oh. and type in 1 dot. Control A, no. Oh, we're gonna take a quick change real quick on this 1.2. There, and show run. And as you can see, okay, I went based on the default network. So now that that's set up, we have our default router, default server, we have the range that it's going to allow us to do. We have our excluded address. Now what we're going to do is we're going to go and we're going to configure, when it comes to, let's show IP route real quick. Because .8 and .0 are directly connected interfaces or networks, we don't have to worry about routing because the router knows how to get there. So what we're going to do is we're going to minimize this guy and we're going to click on this guy. So it wants to pull up desktop, this guy. Oh, you know what? It's not going to work. And you're like, well, why? Well, because I left a few parts out. So what we got to do is on this guy, is fast 0/1 on this guy needs to be configured as a trunk. So we're going to type in enable, config T, interface fast 0/1, type in switch port, mode, trunk. Now it's down to up and show interface trunk. There. Fast 1 is that, and I will configure 2 and 3 as well. So type in interface range fast 0/2 and 3. Switch port mode trunk. Using the range command, you can do the entire switch range if you want to, that way. And type in switch port. Oh, show interface trunk. So 1, 2, and 3 are in there. Everything's VLAN 1 by default. So what we're going to do is, actually, what's happening right now is they're reconverging because of the fact that I changed some information. Now, I will make this a little quicker here. Type in spanning tree mode rapid, and it'll reconverge so much faster if we do that. Enable config T. Type in, this is switch 0. Dhcp, it should have automatically done it because it should be up by now. Yeah. We're in switch 0. Yeah, it should be up. So we're going to type in do show interface trunk. And fast 1 is, it's auto negotiated a .1Q trunk. So we can go under switch port or interface fast 0/1 and type in switch port mode trunk and do the same thing again. Do show interface trunk. Now it's on. Basically what we've done, we turned auto negotiation off. So Dhcp is not running anymore. We also could put in here switch port no negotiate. Oh, I don't know if that's an option. Yeah, it is no negotiate. What that does is it turns Dhcp off. It will not negotiate the trunking. It will not negotiate. So if the other side is trying to negotiate a trunk, this won't participate in that negotiation. So we're going to hit Control U to kill that line, and we're going to type in end. And on this switch, we're going to configure fast 0/3 and /2 into VLAN 10. So config T interface range fast 0/2 and 3. Switch port access VLAN 10. VLAN does not exist, creating. So that'll allow us to create the VLAN. So N, show VLAN. And there you see VLAN 10, 2 and 3 are in it, so it's no longer going to talk to VLAN 10 or VLAN 1. So these guys are doing their thing. So config T, type in spanning tree mode rapid. could have done all three to switches out of the gate, but that's what we're doing this real quick. Makes life a whole lot faster. Let's see, spanning tree, mode rapid, there. So now the switch port is in that. I'm going to do show IP interface brief. By the way, the do command, which is right here, that allows you to run a privilege mode command in config mode. So you don't have to drop Control Z or N to go back to privilege mode to do a show command. So we're going to type in fast1 is our trunk. So we're going to do that. We're going to go interface fast0/1 switch port mode trunk and type in interface range fast0/2 and 3 and type in switch port access VLAN 20. It's not created, but we're gonna set it up. So show VLAN. Now they're completely separated. So what have I done? Well, basically this. Now we're gonna go back here. Oh, notice how it's got an IP address now. So we're gonna do that. We're gonna set it up again 1.2. So it's getting an IP address. So can we ping our default gateway? 192.168.1.1, and we can ping our default gateway. That's a good sign. I'm going to click on this guy, do the same thing. Desktop, IP config. Now, this is brand new. Dhcp, sending the request. There, it's got an IP address. We're good to go there. This guy. Making, automating your DHCP or your IP addressing is going to make life so much simpler for you. I remember when I first started out, when I was going for my CCNA, there were so many times where I would have like these gigantic topologies where I'd have like 50 users on this side and like 60 users on this side for these gigantic topologies and set up these gigantic VLAN sections, and it took me 20 minutes to type in the same frickin' IP address range. I get so frustrated because not only do you have to type in the IP address, you have to type in the subnet mask and the default gateway. This makes it so much easier. So, wish I would have known how to do DHCP a year ago. It's amazing, huh? So, now that we have that, DHCP is working. We're going to click back on the router. We're going to type in this. So, show IP DHCP. Question. We only have one option in Packet Tracer iOS. The reason I call it Packet Tracer iOS is because it is iOS designed for Packet Tracer. So, type in binding. So right now we have 2 and 3. .2 and .3 are being sent out, and 10 and 11 are being sent out. So now what we would do is if we wanted to add more users to these LAN segments, we could. 4 more on each side. We could definitely do that. Now, what happens if we were to add a switch to the mix on here? Well, let's find out. Be kind of cool, huh? Connect it. And fast 4, too fast 1. Now what we're going to do is we're going to click on this guy. Oh, and it's thinking about it. And we're going to click on this guy real quick. Maybe we can beat it to its enable config T spanning tree mode rapid. There. Now it should have converged already. Still thinking about it. That's okay though. Lovely weather we're having out there today. A lot of flooding in northern Illinois and southern Wisconsin. Almost there. What I'm going to try to do is I'm going to attempt to there it goes. Give my VLAN information. I'm going to do for HT. I'm going to type in interface /1 switch port mode trunk. Okay, that's done. I'm going to type in interface VLAN 10. Type in switch port. Oh, it's not going to work. IP DHCP address. Oh, it does let us do DHCP. Cool. Show IP interface 3. Down. Oh, that's because nothing's in VLAN 10 on this switch. So we're going to go down and we're going to type in config T interface -0/24. Switch port. Access. Excuse me. Port access VLAN 10. And show IP interface 3. IP address is still unassigned. Interesting. I was just curious if that would actually work. I'm not going to troubleshoot that. But now that we have that, now since we have a local server and we're going to configure the same information on this server or here on the other server. So we're going to do show run, and then we're going to copy this information. Take this just like this. Copy. Click on this guy. Enter. Enable. Config T. And paste. There we go. Let's assume for just one moment, just one, that what we're going to do here is this guy and this guy don't have IP addresses, so they're not going to talk to each other, and I'll prove that. Show IP interface 3. No IP address. Oh, I just turned it down. So they're sending packets across, but they're not actually routing. So what I'm going to do is I'm going to go to global config, give interface fast1 and IP address, or fast0 interface fast0/0. IP address is going to be 10.1.1.2 255.255.255.0. So end, or actually exit, type in router EIGRP1 network 10.1.1.1 0.0.0.255. What does that mean? Well, any interface that is configured with the 10.1.1.1 IP address, EIGRP will send out hellos out that interface to other routers that are running EIGRP with the same network number and the same wildcard mask. It means that the zeros, 0, 0, and 0, all those, they must match. This last octet, the 255.0, does not matter. It means that any one of the 254 IP addresses that might match will get routed. So end, show IP route. So currently it's just doing that. So we're going to click on this guy, and we're going to go config T, type in config T, type in interface -0/0, type in IP address is going to be 10.1.1.1 255.255.255.0, and type in exit, type in router EIGRP1, type in network 10.1.1.0 0.0.0.255. Well, what happens if I type in .3? Well, it'll only let so many through. But I'm going to type in Control A no network, and then the adjacency will fall. So I'm going to type in 255. Oh. There. So EIGRP is running. And show IP route. So it knows about that one. I'm going to go to global config again. I'm going to type in router EIGRP1. Type in network 192.168.1.0 0.0.0.7, and I had to put in a .8. End. So IP route, it sees it now, and we're going to go back over here to router 1, sees it, and it sees it as /24. Cool. So So now we should be able to do this. Under config mode, type in under interface /0/1, type in IP helper address and destination IP address, not the local interface, destination 10.1.1.2. So there. What does that do? I'll show run. Now we have a helper address under fast0/1 that allows us to, you know what? I know what I config G. Forgot that it didn't have some interfaces here. So interface fast0/1, type in no IP helper. Control A, no. Type in interface fast0/1.10. Type in IP helper 10.1.1.2 and .20. I find that if you type it in underneath the sub-interface, the packet tracer works. You may be able to type it in underneath the interface, the physical interface on a live router, but I don't know. Show run. So now we have the IP address of helper address. So what we're going to do is we're going to go to global config and type and turn off Dhcp. So this to have notepad. Beautiful. No. Now the idea of this is to get the remote router to be the DHCP server and the relay agent to work. So we're going to come over here, we're going to go paste and show run, and all that DHCP information is now gone. So we're going to see if this will still work. And there it did. So now that is how you set up it remotely. Now, that being said, we're going to kill this. We're going to kill this connection right here. Well, why are you going to do that? Well, I want to show you the difference between having it on a crossover cable on the same network being broadcast and a non-broadcast. We're going to do this. We're actually going to turn the router off. Well, if we do that, and so it's just right mem. Right mem. So now we save their config. Same thing with this guy. Now we're going to power cycle it. Do this. Same thing with this guy. 2T. And I don't need a WIC 2T, but same. It is what it is. And clock rate. This guy come over here. 0, 0 to 0, 0. Now what I'll do is, since the routes are already up and running, main line. Enable config T. Actually, I'll do show run, and I'll pull this information off of here. I don't need to. Oh yeah, I still need to put an IP address in. Interface 00/0/0. Type in IP address is 10.1.1.1. and 255.255.255.0. /0. Oh, okay, no problem. So, oh, I got you. Click an interface /0. Okay. Delay, no. Okay, that'll do that. And interface serial. There. Now we have that. What we're going to do real quickly here. This should only take me just another couple seconds here. And we're going to do this guy the same way. Mainline interface. So enable show IP interface free. And we're going to see it's up down because it's nothing's plugged into the other end. So we're going to come in here and go config T interface /0/0 so they can no IP address. So the interface 0/0/0/0. Type in IP address is 10.1.1.2 255.255.255.0. There. Now EIGRP is running. Now you have to go back over to the other router and this guy here, and it works. So Dhcp is working whether we have it across a serial connection or we have it across a crossover connection. And we have inter VLAN routing. So actually what I'm going to do is I know my IP address of this guy. I'm going to slide that over in front of this guy and click on this guy and do the same thing. What is my IP? And then that guy over here. And I'm going to kill this guy, do to this guy. We're going to ping 192.168.1.11. And there it goes. Took it a second for it to ARP to it, but it finally got there. What about .10? It's going to ARP for that one because it doesn't. What it's doing right now is it's ARPing for it because it doesn't know the MAC address to get there. So let me explain that real briefly. What I mean by that: when this guy sends a IP, or sends information to this IP address, this guy right here. Actually, if I don't know if it's going to work. No ARP. No MAC. Yeah, it only knows the one. So what ends up happening is this guy right here sends an IP, wants to get to this IP address here, but it doesn't know the MAC address of how to get there. So when it hits this switch right here, this switch has got to ARP for its MAC address. So it sends a message all the way down here. But because this switch knows how to get there, what it does is it says, I need to know the IP address of this guy. This guy knows it, so it ARPs. Do you know it? Nope, sure don't. And then by default, if it doesn't know the IP address or the MAC address, it sends a broadcast out on all ports except for the one that it learned it, it received it on. So we come in fast 3, but it wouldn't go back off fast 3. It would go off fast 2 and fast 1. Fast 2 receives it on fast 1 on this switch and says, yeah, I know the MAC address. Sends that information back to this switch. This switch says, yeah, I know how to get there. This is its MAC address. So layer 3, the IP field has this IP address, but has the MAC address of this guy because it's all transparent. Now, if it was trying to get to, and because of the fact that it's being routed, it's actually, and I'll take that back. That's if it's all transparent. Yeah, this guy gets the IP address, so it gets the IP address of this guy. And the MAC, or it knows the IP address, or the MAC address of this one, but it knows the MAC address of this guy. So it sends the MAC up here. This guy sends it out. It sends an ARP out. Learns the MAC address of this guy. Sends it up here. It learns it. So let's see if this guy knows the ARP. Show ARP. It does. 10 and 11 from .2. So that's how that knew about it. So that's it, folks. We have configured, I explained DHCP, DHCP relay, the helper address, what a VLAN is. Oh, a VLAN is a logical separation of a broadcast domain. So a VLAN equals a broadcast domain equals a subnet. So So for every VLAN you have to have a equally configurable and addressable subnet range and broadcast domain in order to do that. So what you can do is you can have each department its own VLAN, so that you can limit broadcast traffic, you can control traffic flows, stuff like that. So VLANs are really handy. Now if you're routing them with no control, you're not setting up an access list or anything like that, it's no different than having everybody on the same VLAN, except for the broadcast traffic is a little bit different. So I configured a local DHCP server. I configured a DHCP server on a remote router. All I do is copy the config from here, put it on this guy. That's it. Pretty simple, pretty straightforward. This guy was in the computer. Oh, he did 1.5. So now he has an IP address. That's DHCP assigned. Yes, you can IP address any device interface on any device that's out there, whether it's a router, a switch, an end user, a server, whatever. As long as it's got an IP address or a MAC address, it'll work. That's it for this one. I hope this has been at least kind of informative for you. You get an idea of how to configure DHCP and relay agents and stuff like that, and get them across both on a local subnet that you might have or across a wide area connection like this is simulating. If you have any questions, give me a shout. My email is rriker82@gmail.com. Don't be afraid to give me a hit. I appreciate everybody that's subscribed, and I hope everybody's learning stuff from me. I hope this has been informative for you, and I'd like to thank you for viewing.